Hi, welcome to another scriptr.io tutorial. In this tutorial, we're going to demonstrate a LoRa proof of concept with the STM32 Discovery Kit, LoRa Sigfox node, the MultiConnect conduit, and of course, scriptr.io. You can also follow a written guide on our blog. You will find the link in the video description below. To complete this demo, you are going to need the STM32L0 Discovery Kit LoRa Sigfox board, the X-Nucleo IKS01A2 Motion MEMS and Environmental Sensor Expansion board, which you're going to install on the STM32 board, the MultiConnect conduit, which should be equipped with the MTAC LoRa card and LoRa antenna. With this configuration, the STM32L0 device will read the sensor readings from the sensor expansion board and send it to the conduit over LoRaWAN. The conduit will then forward this data to scriptr.io, where your app will process it, store it, and visualize it. The user will be able to see the sensor's current and historical values on a dashboard and modify business rules for event logging and notifications. Before you start, download and install the Keel Microvision IDE. The link to it is under the Software Prerequisites section in the tutorial. You can find the installation and software activation instructions here on the ARM Keel download page. You will use the Keel Microvision IDE to modify the application on the device and have it read the values from the sensor expansion board. For that, you will also need to download the LoRaWAN software expansion for STM32Q from the ST website. You will also find the link for it under the Software Prerequisites section of the tutorial. When you open the download page, you need to click Get Software, sign in, then download it. Extract the downloaded package on your PC, and we will come back to it later to open it in the IDE. Finally, you need to register to scriptr.io if you don't have an account already. You can either follow the registration link you find in the tutorial under the Software Prerequisites section, or go to scriptr.io/register and enter this promo code. Fill out the registration form and submit. Then click the link in the verification email, which you should receive shortly afterwards, to confirm your email address. Then log in. On your first login, you need to wait a few seconds as scriptr.io installs the device's application on your account. If you already have a scriptr.io account, then you need to check out the device agnostic app from GitHub and run its installer file. Make sure to read the installation instructions in the README file to learn how to do it. Now that you have a scriptr.io account, you're ready to start configuring the device. Let's start with the MultiTech conduit. In your browser, navigate to the administration console and log in. We first need to configure the LoRa network. From the left menu, go to LoRaWAN and click Network Settings. In this interface, set the LoRa mode to Network Server. Then select the appropriate channel plan based on your current location. If you're in the US, you need to select US 915. Set the frequency subband to 1, then set the network mode to private LoRaWAN and confirm. Then submit your changes and navigate to the key management section from the left menu. Set the joined server's location to local key. In Local End Device Credentials, click Add New. Set the fields to the values you see on the screen, which you can also find in the tutorial under section 3.2.2. Click Finish. Then submit your changes. Then navigate to Devices. And click Add New to create a new device for the STM32L0. Fill in this form as follows. The device name here is optional, so you can skip it. Then click Finish. The LoRa settings are now saved. Click Save and Restart for your changes to take effect. Click OK to confirm. The reboot process will take a couple of minutes. Once done, the window will reload and you will be redirected to the login screen. Log back in and navigate to Apps in order to install the Node-RED app that will forward the incoming device messages to scriptr.io. Click Launch Node-RED to open the Node-RED editor. It might take a while to launch after the reboot. To install the app, go to section 3.3 in the tutorial and locate the app's code in step 7. Select it all and copy it to your clipboard, then switch back to the Conduit's Node-RED editor. Click the menu button on the top right corner, select Import, then Clipboard. Paste the copied code in this dialog and click Import. Then click anywhere in the editor to place the new nodes. Now you need to configure it to match your scriptr.io configuration so that it can connect to the right topic using the right credentials. Double-click the MQTT node to edit it. Then click the pencil icon to edit the security details and switch to the Security tab. To get the settings, you need to go to your scriptr.io workspace and open the Messaging Protocols window. In this window, you need to select the device whose credentials should be used by the conduit to authenticate against scriptr.io. Select My Device, copy its username by clicking this button, then switch back to Node-RED and paste it. Then do the same for the password and click Update. Then go back to your scriptr.io messaging protocols and select the device digest channel to be used as a topic to publish the messages to. Copy the messaging topic, then switch back to Node-RED and paste it in the topic field, and click Done. To save your changes to the conduit, click Deploy. Once deployed, the conduit will be ready, so you can now start configuring the STM32L0 board. Connect the board to your PC using a USB cable. Make sure to connect it to the ST-Link port using a micro USB cable. As soon as you connect it, your PC will recognize it as a new drive, and a new Windows Explorer window will pop up on your screen showing the drive's content. In order to view the device output, open a terminal tool. We're going to use TerraTerm. When you open it, it will prompt you to create a new connection. Select the serial port option and you will be able to select the ST Microelectronics ST-Link Virtual COM port. Click OK. Then go to Setup and select Serial Port to configure the port settings. Here you only need to set the baud rate to 115/200 and click OK. Now open Microvision. From the Project menu, select Open Project. From the dialog, locate the project under the directory where you extracted the LoRaWAN software expansion. From the toolbar, click the Target Options button. Switch to the C++ tab, and in the Define field, you need to change the region. Here, I will set it to US 915, then add Sensor Enabled. Then click OK. Then navigate to the commissioning.h file and open it. On line 85, set the over-the-air activation constant value to 1. On line 90, set the LoRaWAN public network constant value to false to create a private network. On line 97, set the static device EUI constant value to 1 to freeze the EUI. Then save your changes. In Keel Microvision, generate a build by clicking Project, Build Target from the menu. Click Load to load the application to the device. When the load is over and the LED on the board is steady green, press the black button for it to join the LoRa network. The join procedure will take around a minute. Then the device will start sending messages to the conduit every few seconds. If you want to check if the device successfully joined the conduit's LoRa network, go back to the conduit's web console and log in. Then go to Devices under LoRaWAN. You will see a new session here. Go back to scriptr.io to run the application. Open the Livestock Fitbit folder and double-click the index.html file to open it in the editor. Then click View to open it in your browser. Log in using the credentials demo. You will land on a map view, and you will see your device in this default location, which is set here to simplify the application as the device doesn't send GPS coordinates. But you can change the code, of course. Zoom in on the device and click its marker for a quick view of the sensor's reading. All the readings in this application are displayed in real time, so the values will be refreshed as soon as you push the blue button again. The View Dashboard button will open a dashboard showing the current and historical readings. The Alerts button will display a log of events where the sensor's values exceed certain preset thresholds. To modify these thresholds, navigate to the Rules Designer from the left panel and edit the values you see here. This column shows rule number 1, which states that if the temperature goes above 8 degrees, an email is sent with a high temperature warning and an alert is logged. Rule number 2 states that if the humidity goes above 30%, a humidity warning is sent by email and an alert is logged, and so on. To specify the email address that will receive these warnings, go to Notification Settings, write the email address and click Save. This is how an email warning will look like. As I'm sure you've noticed by now, the application source code is in your workspace, and you're free to modify it to meet your requirements. For that, you need to check the documentation in the app's README file. If you have any questions, feel free to send a support request from here or send us an email at support@scriptr.io. Thank you for watching.